Hey, what's guys, welcome back to the channel. This episode is going to be all about Victron, and on this episode we're going to show you and walk you through how to set up a 2-unit 240 volt split phase system paired with what I believe is the best battery combination, making it a complete off-grid system, which is really rock solid with good quality and capabilities. And later on we're going to do a load test by charging the Tesla. So let's get to it. These two units are exactly the same. It's the same unit in two, and that's kind of what you need in order to set up a multi-unit system with Victron, especially if it's going to be split phase. And this is the MultiPlus-II series, the 48 volt 3000 VA 35 amp charger. So what that really means is it's a 48 volt system. 3000 VA is volt ampere, so if you want to convert that to real power or watts, obviously depending on whatever load you put it, you want to take 3000 times 0.7. That's pretty much how many watts it can do for most consumer electronics. If you have like other electronics and stuff, more inductive loads, you may want to use a different power factor, but Victron rates these in VA. I just told you pretty much an easy way to convert to watts in case that's what you really wanted to need. And this is a 35 amp charger, which means it can charge your 48 volt battery at 35 amps. Granted, you're giving it enough juice to do that, right? So with these MultiPlus units, it also has an automatic transfer switch built into the unit, which is also really great quality. And on this specific unit, it has a transfer capacity of 50 amps, okay? So this is a 120 volt inverter. And if you are shopping around for Victron inverters, make sure if you're in the US, you're looking at the US model. And if you're, let's say, everywhere else like Europe or whatnot, make sure you're looking at the European model, because they do make units that are 230 volts for Europe and 120 volts for US. You can technically get the 230 volts US, but you'll probably need to step it down using an auto transformer, and that's a probably more advanced series we'll probably cover later. But the point is, make sure you get 2 units that are exactly the same. All right, so I will also go ahead and say this unit is only 3000 VA. They do make this MultiPlus-II series in multiple different let's call it voltage ranges. So they make a 12 volt model, they also make a 24 volt model and a 48 volt model. There may be other models stuck around somewhere else, but those are going to be the primary models you have. And on each voltage, there are other units for, I think it was like 2000 VA, 3000. I think there's also a 5000, 8000, 10,000, 15. So it all varies. And depending on which model you really get, the transfer capabilities, the charge capabilities also change according to that unit, right? So just make sure you keep that in mind. In this example, obviously, we're going to be using 3000 VA units, but when you are getting one, and you're going to set up split phase, make sure you get 2 that are going to be exactly the same. All right, so first of all, going up on here, the front panel, this is a charger side. It tells you pretty much the state of charge that's going on as you progress through your charge state. This also is obviously an inverter, so it'll tell you that if the inverter is on, if it's overloaded, low battery and all these kind of things to it, right? So this is a low frequency toroidal based transformer. So unlike the other inverters that we've seen so far on this channel, which are mostly high frequency based, this actually uses a really big and heavy transformer to pretty much convert the voltage and the power from DC to AC. So Victron, I believe, is one of the few. Most of all of the other ones currently on the market are going to be high frequency transformers. If you don't know much about that, we'll probably try to cover that in a different video, but just know that there are 2 different classes of inverters that are currently available on the market. We're not going to get into the pros and cons of each one, but we will point out with a low frequency inverter, you can handle a lot higher surge capacity, and it is also significantly heavier than a low frequency based unit of the same class. Coming around to the connection, let's talk about this. This right here is your AC1 block, here is your AC2 block, and here is your AC in. This white cable here is your standard Ethernet cable. It's connected to VE bus, and the other end of this cable is connected to the other unit on VE bus. This connection right here is your inverter ground, and then it's connected right now with the 10 gauge wire connected to the other ground points on the system. This right here is obviously your DC in. So plus minus, and here is a switch which has the position 1 and 2. Depending on which position you put it in, it can do charge only function, which means the inverter won't be on, or you can just turn it to on, which means it's on full operation mode. All right, so let's talk about AC 1 and 2 and AC in here real quick, mainly because this has what the automatic transfer switch built in, as we talked about earlier, right? So first of all, AC 1 out has a ground, neutral, and a hot. The AC2 out also has a ground, neutral, and a hot, and AC in has a ground, neutral, and a hot. And remember, this is a 120 volt unit, single phase unit. What that really means is there's only 3 wires, right? So on this case, if you have AC connected in or AC in connected, you do have to connect it to both units, right? So when AC in comes in, it powers both AC1 and AC2. But when power is no longer available or coming in, the automatic transfer switch built into here transfers the AC1 circuit only to be powered by the inverter. So what that really means is it's pretty much like a UPS unit if you've used them before. If you look on the back, you know, there is what they call like surge only, right? And then there's another chain of circuits which are battery backup. That's pretty much exactly what's happening here, right? Except on a, you know, much larger scale, so to say, mainly because AC2 out is not powered when AC in has no more power, and then AC1 is always powered whether you have AC power or not, right? The beauty of these transfer switch units also is that, besides it being automatically built into the unit, is that it's a really fast cutover. So if you have sensitive electronics, you don't really have to worry about, you know, the cutover speed, because it's almost instantaneous, right? So the computer and stuff you have connected to this type of unit, you won't really have any issues with that. So backing up out of here, let's go ahead and talk about the connections to the units real quick. So this is a RJ45 Ethernet cable, standard cable that comes out of this unit, and it connects to VE bus on this unit. And there are 2 ports. It doesn't really matter which one you connect it to, because it's pretty much, think of it like an Ethernet type switch, right? So it doesn't matter whether you connect it on the first port or the second port for VE bus. As long as they're connected together, that's all that really matters. There is a second Ethernet cable that comes out of here, and that connects it to the Victron Cerbo GX. We'll talk about that in a second. But you can connect the Victron Cerbo GX to either this unit or this unit. It really doesn't matter as long as the Victron Cerbo GX is connected to any one of these inverters using VE bus. That's the beauty of VE bus. There is another type of communication protocol which we don't need to use in this type of situation, but that's how that really works. And as you can see here on this unit, the AC1 is connected with neutral, ground, and hot. But in this case, we used a red wire on this unit because, you know, it is one leg of a 240 volt circuit. And on this leg, we used a black wire because it is another leg of the 240 volt circuit, right? So if you look at it each way, the voltage across or coming out of each one is in 120 volt split phase, right? Here, but if you take the voltage across the hot and the hot, because they're 180 degrees out of phase, it will be 240 volt split phase. So this unit right here is the EG4 indoor wall mount battery, and I believe this is the best battery for this type of system. We're going to talk a little bit more about that in just a second. I would highly recommend getting this battery, but also if you're going to get this battery, I would highly recommend getting this unit right here, which is the EG4 indoor wall mount batteries conduit box, which is designed to be used with this unit, right? They are sold separately unless somehow they start selling them in a kit, which I haven't seen. So make sure you get the conduit box. I believe it's worth the extra, was it like 100 bucks or so or whatnot in this case, right? So down here, we'll talk about the battery more in a bit, but on top of the battery itself, the reason it's really popular is that it's a 14, I believe 0.8 kilowatt hour battery pack that you can mount on a wall. This battery is indoor rated only, right? So, you know, obviously these inverters are also indoor rated only, so it's a good pairing. But on top of that, this battery comes with these connectors, right? So it does come with 2 black cables and 2 red cables. These cables are 2-aught cables, and because there's 2 of them, it actually works perfectly, 1 pair for each battery, right? And not only that, the battery also has 600 amp bus bars installed on top of the battery, right? So this battery is really popular for many of those reasons, but also The connections to this is called a quick connect. Some people may call these, what do you call it, Amphenol connectors, but I would say technically that's incorrect because Amphenol is really a brand. Amphenol is really synonymous with this type of connectors kind of because they made the connection really popular, but then other brands have kind of picked up on it and kind of made it more like they kind of built off of it, right? So this connection right now is what they call a quick connect, but this brand is called the VIctron connector. And if I can get one out of here, see, it uses a quick connect cable like this, which this cable comes already crimped like this, right? So all you have to do is you press this in and then you wait for it to snap, and once it snaps, it's a good solid connection, and these connectors are rated to carry the load that these cables can carry, right? So as you can see here, there's 4 slots, right, on each side, on the negative side and on the positive side. So that makes it really nice to use. The white cables in here, stuff we talked about already. This box is also grounded to the grounding unit, right? This green cable here on the corner is for this front panel. Just know that all of this gray stuff you see in here is actual metal and not plastic, all right? So with that, this blue cable here is a battery BMS communications, and the other end of this blue cable goes to the Cerbo GX. We do have a separate video completely dedicated to BMS connection between this battery and the Cerbo GX, so if you're interested in that, make sure you check that out. All of this stuff in here is pretty nice and tidy pretty much once you close the box, but like I said, everything in here is really included when you get this, except for pretty much the Ethernet cables, which are, you know, going to be ubiquitous. You can find them pretty much anywhere, right? So you probably already have some laying around inside of your house. And this right here is the battery screen. The battery screen is really nice to have because you can actually tell, you know, pretty much all the specifications you need, what's going on with the battery, but also on the battery screen is also this fuel gauge built in, you know, denoted into like 4 different sections of how much battery capacity you have left, and the screen also tells you how much battery capacity you have left, so that's really nice to see, right? So I'm not going to go in super detail, but like I said, the voltage is here, the capacity is here, the amperage you're drawing is here, and then the mode is here, right? So if you're right now it's on standby because I don't have the breaker flipped, but if you're charging, it'll say charging. If you're discharging, it'll say discharging, and it'll also tell you at roughly how many amps it's going in and out, right? All this other stuff on here, right now I have it set to VIctron communication, so that's what this CAN bus really says, but also, you know, voltage, and you can go in and check all the cells temperatures and voltage and stuff like that, but we don't need to get too much into that. Just know that this battery, we also have a separate review of this, like I said, but this battery is a really good unit for this because you also get a lot of visual feedback from this screen. So moving on to the monitoring part of this unit, this is the Victron Cerbo GX, and this is pretty much the monitoring unit for this entire Victron system. And this can do a lot of different capabilities, but I'm going to tell you what we have covered in here, or set up in here, which is, this is an HDMI cable that goes to a screen. You do have to buy the screen separately. And then this is the pretty much power and also feedback that kind of comes back with that screen, because it is a touch screen. This white cable here is the cable that we showed you earlier that connects to one of the inverters. It's connected to the VE bus here, and then this blue cable is the another custom-made Ethernet cable that we made that connects the BMS bus CAN port to the battery, and that way this entire system knows what's connected with the battery, how much is going in, out, capacity, all of that stuff, right? So this unit we have set up for Wi-Fi communications. It does communicate via Wi-Fi to what they call the VRM portal, which you can log into online and also see, right? But you can also connect to using the app and also see. So it's really nice to have because you can look at it from remotely. You can be completely not close to the system and look at it remotely, and you can look at it in person because there's also a screen, and you can also use the app, right? So this is a really nice plus to have. I would definitely recommend spending what is like the $200 or what it was to get this unit, mainly because you definitely want monitoring metrics and all that stuff about your system. That way you know what's happening at all times, right? This cable right here is just a power cable that's connected to the battery. It does have to have a battery connection. It is fused, but it does take one extra connection. So this right here is a Touch 50, and this Touch 50 is connected to the Cerbo GX using the HDMI cable and Ethernet cable we showed you earlier, right? So it is a touch screen, and right now we do have it on, so we're not going to touch any of the connections. But this red icon, red box here is your grid power. I don't have grid connected, but if you had grid connected, you would see transmission lines and also power flowing if we were consuming it, right? And this right here is your battery box. Right now the battery is at 87%. It's pulling 63 watts at 53.2 volts and 1.2 amps coming out. The flow of dots, as you can see here, is the flow of electricity. So in this case, the electrons are flowing out of the battery and going into the inverter. Here's the status of the inverter. These little dots here, you'll see on the right side, it is reflective of the dots that's actually on the inverter, right? So in case you had the inverters mounted somewhere remotely, whatever dots are on here, it's going to be exact replica of what's going on there. So this inverter system is inverting, as you can tell, and then right now we do have AC loads connected to it. It's just a really small fan, so it's only drawing like 40 watts, but line 1, which is, you know, only pushing 6 watts. So if you want to look at it in terms of idle consumption, you could kind of argue this is 5 or 6 watts of idle consumption with the inverters being on and no load being powered. But I think it's actually a little bit more than that. We'll have to double check, but you know, nothing is really happening right now on this one inverter. So I will cover real quick because I know some people are worried about line balancing. So on this type of system, because you have two transformer-based inverters in a way set up for split phase, you don't really have to worry about line balancing as much as you would in a high frequency single unit 240 volt split phase inverter, right? Because those units use high frequency inverters. You have to worry about line balancing in order to balance it out. But in this type of system, you don't have to worry about it as much because the line limit is going to be capped at the capacity for the smallest inverter or any single inverter, because you have to use, you know, matching units, right? So in this case, the maximum line balance, unbalanced this is going to be able to handle is, let's just say 3,000 or up to 3,000 VA, mainly because that's the size of this inverter. But you know, if you wanted to draw one, let's just say 2,000 watts from one inverter and then nothing from this other one, you won't really have a problem with that in terms of it being able to handle that. But you will have an issue trying to maximize the output of your entire system, because you know you're going to be capped at that. So in case you're wiring it to a load panel, you definitely have to keep that in mind, because you know the smallest inverter is going to be the weakest link in this kind of case. But if you're worried about, you know, oh, we got big devices coming on and off line that are single phase, then that's going to be, you know, a small problem, but not really a problem in this type of system, right? So another beauty of this type of system. Here's another way to look at the screen. It's pretty much the same information, just really more of boxes telling you what to do instead of diagram. If you click on it, you can go into this thing called menu, and you can go into all types of stuff. We're not going to go into everything in detail, but we will cover some of the basic stuff. Device list will tell you all the devices that are connected. So obviously we have the EG4 indoor wall mount battery connected, but it comes up as EG4 LL. The specs of the battery are in here. If you go in here, you can tell the state of health, charge, alarms, parameters, and all kinds of stuff. So because we have BMS connection communications working, all of the nice stuff you need is really in here. This right here is the state of your inverters. Tells you what's going on, if the AC input is active or not. So like I said, not all the details, but it tells you also in here the specs of everything, right? So it's really nice to have this because you can see all the specs of all the stuff going on with your system in person in front of your system, and also online if you have it connected to the internet. Notifications is here. Right now there's no notifications, but settings allows you to change pretty much all the stuff going on with the system. We're not going to go into every settings here because we will spend hours just going over the settings, but out of the box you need very minimal configuration in order to get it to work. You just need to install it, connect the cables, change maybe 3 or 4 parameters, and you are good to go. So this right here is the load panel or the load center. This unit is a load center and not a sub panel. So let's talk about how it's going on up in here, right? So this black wire is the one inverter coming in. This other black wire is the other inverter coming in. The neutrals go to the neutral bar, and then the grounds go to the ground bars, right? And the hots connect to this 2-pole breaker. This breaker right here is, power going out, so don't worry about that one right now. But right now, the neutrals are on one bus, the grounds are on another bus, and then the ground neutral bond is happening right here with that green bonding plug. So a load panel will come with that. But in any system, you really need just one spot to do the neutral and ground bond, and in this system, it's happening right there, right? So if I go ahead and take this multimeter, see if you can see it on the screen, you can kind of see it there, right? So if I go from hot to hot, right, you should get 240 volts, because that's how split phase kind of works, right? So you can see right there 240 volts. I hope you can see it, because I can't see the camera on what you see. But if I go ahead and go from one leg to ground, you should get 120 volts, that you see right there, right? And if I go from the other leg to neutral, I don't know if I said ground or neutral, but neutral, you get 120 volts, right? So 120 volts each leg, but if I go from hot to hot, you should get 240, and that's how split phase, that's where the split phase naming really kind of comes into play, right? So that's how that is. This right here is connected to a 30 amp breaker using a 10 gauge wire going out. It's going out to, I think it's like 1450 plug, and that's how we're powering just one load. But that's how the load center would really be connected. 50 amp outlet to connect the Tesla mobile charger, and the Tesla mobile charger is on and connected to this Tesla over here. So this Tesla is currently being charged. If we go take a look at the screen says there's about 4,600 watts going into the load center, and right now, because the load center only has one circuit, that's pretty much only the Tesla. And if you look here, L1, L2 is each inverter respectively. So each inverter is pushing roughly around 2,300 watts. This right here is the EG4 indoor wall mount battery. So we got about close to 5,400 watts coming out of the wall mount battery, which is about 105 amps, going into the Victron inverters. And the inverters are pushing 4,600 watts into, right now, this Tesla mobile charger. So this right here is only set up for a load test right now. Obviously do not set it up this way, or clean it up and make it more compliant. Obviously don't have all these cables and stuff like that hanging down. So like I said, this is only for a test, temporary, not to be installed this way permanently. But if you want to know, can the Victron MultiPlus 48 volt off-grid inverters be used to charge a Tesla, right, at 240 volts? The answer is definitely yes, right? Because right now we're charging roughly around 4,600 watts, but that's because right now we only have 3,000 VA inverters, right? So if you want to charge at faster or higher speeds, I would definitely encourage getting the 5,000 VA inverters, or the 10,000, or even the 15,000 VA inverters, and then you could get maximum power pushed to your car or your charger or your load center, whatever you want to do, right? Obviously, you're going to have to upgrade the wires, and you're going to need more batteries if you're going to push that many watts or power into it. So that's how the system works, and that's how it's configured, right? And speaking of configure, let's talk about this. So you do have to program these inverters to work in split phase. We do have dedicated video on the channel on how to do that. We use the Victron VE bus to and a MacBook to kind of get that working. So it's pretty straightforward. We were able to figure it out on our first try. I don't really see anybody having too many challenges with that. In case you're going to go through it, I will say it doesn't really matter which one you select as L1 and L2, because it's only a 2-unit split phase system. So which one is L1, L2, it's not really going to matter unless you're going to be having issues, or you think you're going to be having issues with the load and it like cutting off, but then you obviously see that on the face of the inverter. So, just point of note, right? So anyways, other than that, let's go ahead and talk about some of the pros and cons, right? So the pros and cons to a low frequency, a transformer based inverter is going to be that one is that they're hefty. A lot of people are going to say that. So if you're going to install this in a place where weight is a concern, obviously take that into account. But I will also point out, because it's a low frequency transformer based inverter, it doesn't have a lot of other electronic circuitry as you would in a high frequency inverter. And most people know high frequency inverter electronic circuitry a lot of the stuff will eventually fail, right? Obviously, everything fails eventually, but it just seems that anecdotally speaking, the failure rate or chances of a component failing inside of that entire circuit board is going to be higher if you have more components, right, versus a transformer. So that's also something to take into consideration. But I do want to point out something with heftiness, mainly because everybody always says, you know, oh, they're going to be heavy, right? So the point is, if it's heavy, yes, it's a downside, but you only have to deal with it once, right? So when you're installing it, once it's installed, it's not like you're moving it a lot unless you're just always mobile or something like that, right? But if you're installing in a stationary system or even in an RV, you're just installing it one time, you know, is that really a concern? Just, you know, something to think about, right? The other thing to point out is that these units, as we talked about earlier, have transfer switches built into it. We do have video showing the transfer switch. If you want to look at that, go take a look at it, which is a huge plus. But you know, other high frequency, you know, all-in-one systems will also have transfer switches built into them. So you know, that's also not, you know, too much of a huge plus. But the other plus is that the good all-in-one units will have a good cutover time. This one will also have a good cutover time, right? So that's also really good to know, right? And as I mentioned earlier, these inverters paired with the AG4 indoor wall mount battery is a huge plus. Cables come with it. You get a conduit box. The battery has, you know, communications working. It's got a screen. You got bus bars, everything you need, right? So you just need to buy just a few components, a few cables, wire it up, and you're good to go. And if you have capacity issues, you can always just get bigger inverter chargers, right? These are actually called inverter chargers, but I've just been calling them inverters, mainly because if you have AC connected, you can use them to charge the battery, right? So we obviously didn't talk about the solar component, but mainly the solar component is going to be straightforward. You'd have to have another unit, which is going to be a solar controller. It takes the solar energy and uses it to charge the battery. You know, that's really straightforward, you know. So if you want to know more about that, we can talk about that later. But the point is, this is a really good system, and I really do think that this system will work, you know, pretty much a long time. For a while, we've actually been using it to charge the Tesla, just to like load test it and stuff like that. But you know, we haven't had any issues, and I can't imagine too many people having issues. So if you do have an issue, post in the comments below, because I would really like to know about it. And besides them running silently and just always working, you know, I don't know what else can really go wrong. Like I said, issues, questions, concerns, let us know. Otherwise, have a great day. Get back to work. Thanks for watching, and we'll see you guys next time.